Here's an example of an integral that requires using integration by parts multiple times. This can seem confusing at first, but hopefully by the time you go through a couple of them, you'll get the hang of it. So we have the integral of e to the t cosine of 4t dt. Because I see the e to the t multiplied by the cosine of 4t multiplied together is a clue that integration by parts is probably a good idea. When I choose my u here, I could choose either the e to the t or the cosine of 4t. I'm going to choose u equals cosine of 4t, but it would work perfectly fine if you did this the other way around. And then dv is going to be e to the t dt. Then the derivative du is negative 4 sine of 4t, and v is equal to e to the t. I forgot my dt right here. Okay, now I can rewrite my integral as, remember our formula is u times v, so e to the t times cosine of 4t minus the integral of v du, so e to the t, and then in the du we have this negative 4, which I'm going to come up front, put out front, which ends up making this a plus with a 4 in front, and sine of 4t dt. Now, it appears that we haven't really made much progress. This integral that we have is not really better than the one we started with, but we're just going to press on and do it again. Okay, so integration by parts again, I'm going to set it up the same way. I'm going to choose u to be sine of 4t, and I'm going to choose dv to be e to the t dt. Then du is 4 cosine of 4t, and v is e to the t, and I forgot my dt again. All right, and using integration by parts, first we have this e to the t cosine of 4t from the previous step, and then we have a plus 4 times this integral. Okay, so u times v is e to the t sine of 4t, and then minus the integral of v du is e to the t. I'm going to put the 4 out front. We have cosine of 4t dt. Now, what do we notice? It seems like we haven't made any progress because this integral is the same as the one we started with. Okay. Let's call this integral I for integral. Then we really have an equation that says I equals e to the t cosine 4t plus 4 times e to the t sine of 4t minus 4i. Okay. And now I can just solve this equation for I. So I is equal to e to the t cosine of 4t plus 4 e to the t sine of 4t minus 16i. Adding 16i to both sides gives us 17i equals e to the t cosine of 4t plus 4 e to the t sine of 4t. Okay, then what? To get this integral by itself, we just divide by 17. So I is equal to 1/17 e to the t cosine of 4t plus 4/17 e to the t sine of 4t. Okay, and remember this integral I is the integral in the original problem. Because it's an indefinite integral, we need to tack the plus c on the end. This is our answer. I thought this would be a good time to remind you how we can check that that answer is what it's supposed to be. Okay, so how do we check that this integral, e to the t cosine 4t dt, is actually equal to this function? Remember, an antiderivative just means that if I take the derivative of this, I should get e to the t cosine 4t. So to check we're going to take the derivative. Okay, so I have 1/17, and then I'm doing the product rule. E to the t cosine of 4t minus 4 e to the t sine of 4t plus 4/17 times, now I'm doing product rule here again, e to the t sine of 4t plus 4 e to the t cosine of 4t. Okay, if I distribute, I end up with 1/17 e to the t cosine 4t minus 4/17 e to the t sine of 4t plus 4/17 e to the t sine of 4t plus 16/17 e to the t cosine of 4t. And then we notice that this term and this term cancel. And here we have 1/17 e to the t cosine 4t and 16/17 e to the t cosine 4t. So this equals e to the t cosine of 4t, which is the function we are trying to find the antiderivative of in the first place. So we just checked, and now we know for sure that we have the right answer.